Alright, and welcome to lesson 2.1, where we're going to talk about the derivative and the tangent line problem. In fact, we're going to start by talking about the tangent line problem. So let's first look at a visual idea of what is a tangent line. If we look at the graph of, let's just say, any old curve, we are looking for, given a point, what is the slope of the line that's tangent to the curve at that point? Think of it as the real-world application of this would be like a roller coaster. The roller coaster is, the cars are moving along the track, and if our slope is off just a little bit, that car could fly off of the track. So we're going to start by just calling this point C, or maybe let's call it X, and f of x. Now we can approximate this slope by finding a secant line. And if we recall back to when we took geometry, a secant line is found by taking 2 points on a curve. One of those points will be the x and f of x, and connect them. We won't get the exact slope of our tangent line, but we can get close. In fact, the whole idea of the tangent line problem is we can pick points that get closer and closer, and we will eventually find the slope of that tangent line. So what we can say are these points we're approximating, these are at x plus h and f of x plus h. Now, we want to recall something from back in algebra. What I want you to recall is to find the slope of a line, we can use 2 points. We can take y2 minus y1, the y values from each point, and divide them by x2 minus x1. Now, we're going to look at this as a little different notation, because if we're just looking at purely the tangent line, we've only got the 1 point. If we're thinking about those secant lines, then we've got 2 points. So we're going to look at the slope of our secant line is going to equal f of x plus h minus f of x all over, and if we went x plus h minus x, all we would be left with is h. And maybe you talked about this specific formula back in pre-calc, but this formula also has a name. It's called the difference quotient. So we're going to be utilizing this difference quotient to estimate the slope of a tangent. We're also going to start utilizing a different notation here. We're going to start using, instead of x2 or y2 minus y1, we're going to use delta y to represent the change in y, and instead of x2 minus x1, delta x. So right now, I'm going to give you the definition of tangent line with slope m. So we're going to say if f is defined on an open interval containing x, and if the limit of delta y over delta x as delta x goes to 0, but we're going to replace some of the, not even some, we're going to replace all these delta y, delta x with that difference quotient stuff we were using. So we're going to write this as the limit of f of x plus h minus f of x over h as h goes to 0. This is going to be equal to the slope of our tangent line. So if all of this exists, then the line passing through the point x, f of x, with slope m is the tangent line to the graph of f at the point x, f of x. And that's the definition of a tangent line. So let's look at example 1. What we're going to do is we're going to find the slope of the graph f of x equals 2x minus 3, and we're going to approximate this when x is 2, and we're going to utilize the definition of the tangent line. So what we're going to need to set up is we're going to have to say the limit of f of 2 plus h minus f of 2 all over h as h goes to 0. We're going to try to find this limit. Now we know f of x. f of x is 2x minus 3. So when we're trying to find this limit, we're going to start by going the limit of 2 times 2 plus h, so we're replacing x with 2 plus h, minus 3. I'm going to put all of that in parentheses because then we're going to subtract f of 2. So we're going to replace x in f of x with 2. We're going to try to solve for this. So now let's look at what we've got and what we can clean up. So in this first set of parentheses, we can start by distributing this 2. So we're going to have the limit, I'm going to do my work up here. We're going to have the limit, 2 times 2 is 4, 2 times h is 2h, minus 3, minus, let's clean up the other parentheses too. 2 times 2 is 4, minus 3. We're going to put all of that over h. We're going to say h approaches 0. Now let's clean up what's in our parentheses. In this first set, we can go 4 minus 3, and then how about in the other set we do the same thing, 4 minus 3. So we're going to have the limit of 2h, I'm going to start ditching off my parentheses, 2h minus 1, not minus 1, plus 1, minus 1, because we've got 4 minus 3, which is plus 1, and then minus another 4 minus 3, which is going to end up being minus 1, all over h, as h goes to 0. Now what we've got left here, these 1's, they cancel each other out. And in our numerator and denominator, these h's will cancel each other out. So what we've really got is we've got the limit of 2 as h goes to 0, which means the slope when x is 2 of this line is going to be 2, because we learned in our last chapter the limit of a constant is that constant. Let's look at one more example for this video. So we're going to look at example 2, and what we're going to do is we're going to look at, again, finding the slope of the tangent line to the function f of x is equal to x squared plus 1, and we're going to be looking at 2 points. We're going to be looking at the points 0, 1, and the point -1, 2. So the first thing we need to do is we need to find the equation for the slope of the tangent line. So that means we have to set up that limit problem. So we're looking at the limit of f of x plus h, and we've got x squared plus 1 for f of x, so we're going to replace x squared with x plus h squared plus 1. Put that whole thing in parentheses because we're going to subtract f of x from that. So we're going to subtract x squared plus 1. We're going to put all of that over h, and we're going to look as h goes to 0. Now let's clean it up. If we are using our algebra tools, x plus h quantity squared, if we were to multiply that out, what we're going to get is x squared plus 2xh plus h squared plus 1. And then I'm even going to, while I'm at it, distribute the minus sign to the x squared plus 1. So we're going to have minus x squared minus 1 all over h as h goes to 0. And now I'm going to start looking at what can I cancel out. Well, in my numerator I have an x squared and a minus x squared, so they cancel each other out. I've also got a 1 and a minus 1, which cancels each other out. And then with what I'm left with, the terms in my numerator and the term in my denominator all happen to have an h, so I can cancel out one of those h's. So what we're really looking at is the limit of 2x plus h as h goes to 0, and with direct substitution we're going to end up with 2x plus 0, which means we're going to just have 2x. So the slope of our tangent line, or the equation for that slope, is 2 times x. Now we were asked to do this at 2 points. Our first point, 0, 1. All we're going to do is we're going to take and put 0 in for x. So if we had 2 times 0, that means the slope at that point would be 0. Let's look at the other point. We have negative 1, 2. So we're going to take the x value and plug it into our equation. We have 2 times negative 1, which is negative 2. So that means the slope of the tangent line at these points are 0 and negative 2. So I don't remember if I said this or not, but we do use this tangent line problem when we're thinking of things like roller coasters. If we're off a little bit with calculations when designing a roller coaster, the cars which are tangent to the track could either fly off or they won't have enough speed to get to where they need to be. In our next video, we're going to talk about derivatives.